Welcome to the Vox Pathfinder 15R channel. And today, this is the very first Vox Pathfinder amp I ever bought. It's been giving me some issues, I think. You know, the last video I did is a tribute to the 58,000 Americans who have passed from COVID-19, and a salute to the same number of Vietnam veterans who passed. Seems like I've been getting like ghost noting, or like this weird intermodulation distortion. So today what we're going to do is we're going to check filter capacitors in the main supply area. And I have a good multimeter, transistor tester, screwdriver, some sheets with ESR values for capacitors at different voltages. This one seems to be the most loose of them all. And the other sheets have tighter tolerances. So we're going to sort of check it out. I'm not sure what's a good ESR value, but I'm going to use these sheets as a guide. Obviously, if there's something way out of whack, we'll know about it. Got my solder sucker, and I have my soldering station. So let's start now. Let me just get some of my tools over here. Okay. So I'm going to want to start by taking off the back. I'm going to take off these 4 screws. These screws hold the chassis, which is not a bad thing to take off. But if you want, you could take this whole unit out with the chassis attached, along with this board. But you wouldn't get the access into here. So we're going to loosen those screws as well. Those are all off. Maybe just these down to here. And the screw. Alright. There we go. We got the back panel off. Made of fiberboard. So here's the chassis. And here's the little board. And we're going to want to test the filter capacitors. And I believe that's between these 2 points and some other points over here. But we'll know better once she's out. Unfortunately, a little of this stuff stuck. Oh, that's part of the charm. Yeah, so we're going to want to take, unfortunately, can I peel that back? Yes, good. Alright, we're going to want to take this board off. So it's going to require us to lower this, take out these screws. I'm just holding it. There we go. Easy peasy. Just have to maneuver this out without it getting stuck to the magnet. And just take off the speaker cables. there you go. That's the chassis. And the filter capacitors are right here. So we're going to want to test them. So I'm going to turn on my soldering station, get my solder sucker started, and away we go. And is this still filled? So we're going after these two solder joints and these two. So ordinarily you see people with, they say when you're working with these circuit boards, soldering wick is much safer to the circuit board. I don't doubt that. I just don't have any. Maybe if I pretend the tip, it would work better. Maybe if I was wearing glasses, it would work better even still. I'm going to get a magnifying glass, and I'm going to stop the footage right there until we get those the solder out of those 2 points. And we'll be right back. Okay, so I've been desoldering these capacitors, and I didn't want to bore you. But the capacitors are glued to the bottom side of the board, so what we're going to have to do is going to have to take off all these knobs and take off all these nuts. And we're going to have to want to take off at least these 2 screws which hold this heatsink to the chip and to this back. So we're going to go ahead and remove all these things and get this circuit board out of this chassis. So it's just a very simple operation, so I don't think we need to show everything. But yeah, it just taking off these nuts and washers, that's all that this is, okay? So we're not talking any big deal. So once I get this freed, we'll be able to see these electrical components from the other side of this board. This is the easy side to solder from, or desolder, as the case may be. So when this is all done, I'll show you how it looks. Okay, so we've freed this board. Now you just gotta sort of pull it out, and we have lots of wires in the way. So you just gotta be very delicate as you do this. Let's see. So the only parts keeping this attached now are to these 2 clips to the power switch. So we just want to remove them. And that will probably free up the access to this board. Easier said than done, for crying out loud. Okay. Let's see how that works. There we go. So now we have access to the top of the board, and as you can see, there is glue holding those power filter capacitors down. So what I'm just going to do is I'm just going to gently try and score them away from the board. see how, and then try to free them eventually. It's kind of annoying because if you want to replace these things, it makes it kind of difficult. But I can understand wanting to glue these in place and hopefully they're secure. So that's going to take me a while to free. So I'm just going to stop there. But visually inspected, you know, they look okay. They haven't domed, so a visual inspection doesn't seem to make them look bad. They seem to be in all right shape, but they're probably close to 20 years old anyways. So we're going to take those out and give them a whirl. See how we do that. So I'm just going to cut from there, and we'll be back once these are out. Okay, so it was kind of a pain in the butt, and I was just experimenting with my transistor tester. And since I, removed the solder, these little things have something to clip onto. So when I clipped across this capacitor and did a test, here we have 1.5% V losses, 2131 microfarads, and an ESR of 0.02. Okay, so here it states this sheet 0.14 ESR loss for 25 volt 2200 microfarad capacitor, so it beats that. And this sheet says this is just an average performance of 0.06 ohms ESR, and this is 0.02, so it's a third of that. And on this sheet it's gauging the quality, and this is basically 0.02, and this is the high quality column, not the normal, low, or very low. They're saying normal would be 0.045. Okay. Versus this guy saying average be 0.06. Okay. So that one seems to test good. So we'll just move these probes over to the other capacitor and give that a test. And this one has voltage loss of 4%, 0.01 ohms ESR, 2230 microfarads. It seems decent. I mean, is the voltage loss that big a deal? V losses 4%, but the capacitance value is dead on, right? ESR is 0.01. We look here, that's like almost putting it, it's between here and here, so it's almost putting it into the very high quality. Do that again. 4.3. That's the only, the capacitance dead on, the ESR is real low. I mean, let's see. I could maybe doing the test does something, charges them. Gonna test the other one again. yeah, dead on the money. And this has lower voltage loss, 1.2% V losses. Let me just sort of short them out. Perform that again. Sorry if the wire's getting in the way of the screen. See how that tests. 4% V losses, 0.01 ohms of ESR, 2230 microfarads. Looks right on the money. Perform this one again. So V losses, I don't know, is 4% high. ESR looks good. The capacitance dead on. (1.2% V losses). 0.02 ohms of ESR. 2138 microfarads. So that looks like all in the money. So I'm just going to look for V losses and see what's an acceptable rate, but it looks like I'll probably just be resoldering those guys back in, not taking them out. Okay, so we'll just stop right there. Okay, so I took these filter capacitors out of circuit. I just wasn't comfortable with that, like 4.2, 4.3% V loss with one of these. I couldn't really find much online as to what V loss really means or what's an acceptable limit, but I just had a bad feeling. So once I took them out, I decided to retest them out of circuit. And see what the figures are. This was, I think, the supposedly quote-unquote bad one, and now the V loss is down to 1.5%, ESR 0.01 ohms, 2138 microfarads. That looks good. We'll do the other one. V loss 0.9%, ESR nothing. 2152, so that looks really great. So I'm going to look at the schematic and see where another capacitor nearby could be failing, and we'll have to test that out. Alright, thanks for watching. Okay, so what I've done is gone to the next capacitors in the power filtering section, C33, C34, 100 microfarad, 25 volt caps, and I lifted one leg off the board so we could test them out of circuit. So this is C34, and V loss is 1.3%, 94.4 microfarads, ESR 0.33. If we look through these sheets, 100 microfarad, 0.33 is between normal and high quality according to this sheet. According to this sheet, 1.4 ohms, and we're 0.33. And according to this sheet, 100 microfarads at 25 volts. Here they have 0.3 ohms ESR. and this is 0.32. So that one looks good. Now that's C34. Now we'll go to C33. Hold on one second. Okay, that's one leg and the other leg. Alright, let's test that out. Here we have 1.3% V losses, 94.2 microfarads, ESR 0.48 ohms. So according to this sheet, we're higher than we should be. I don't know if that's bad. According to this sheet, we're past normal going into the low territory. And here, seems like we're still fine. If we were to compare notes, they're saying 1.4 ohms. That would be like past the low territory here. And again, it's 0.3. So, maybe she ain't great. Yeah, 0.48 ohms. I don't know. Depends on what chart you look at. Here, like I said, they're saying a little about normal. This saying 0.3 ohms, and on this sheet, 0.3 ohms would be between high quality and normal quality. Oh, so maybe that one's drifting. So I'm going to look at that, see how that one relates to the position of the main caps, and see if that could have contributed to the high ESR. Okay, we'll be back. Okay, it's the next day, and we have a schematic here of this amp. And here's the power filtering section. And I want to emphasize we've done these two capacitors. These are the big ones. At the 2200 microfarads, these are C35, C36. And then these were the next two smaller ones, like the 100 microfarad capacitors. One of them is C33 and the other one is C34. And then on a whim, I traced this to an electrolytic in the power amp section. C26, I believe. Hold on. Hold on one second. Let me just. Yeah, it's C26. So I'm just going to show that now. But what I thought was interesting, there are these two supposedly 15 volt Zener diodes, and part number on them is 1N5245. So that, they're supposed to be 15 volters. Okay, so just before we go to the capacitor, I just want to show those, how they might be acting a little funny. Alright, so here we got a little transistor tester, the trusty MK168. And we have it around ZD2 for the moment. I get this reading. Now, in the past, I got this reading for ZD2 and this reading for ZD1. Now, here's like the forward voltage, but the other voltage it should be 15 volts, and there it's like saying 2.5. So, let's see, just jostling it, make it change. So that's ZD2. So I'm going to go over to ZD1. Okay. And that's the screen I was getting for both of them. So you have like U forward, 810 millivolts, and 2.49 volts. I'm not quite sure what that's supposed to be. I would think that's the backward voltage end, like the 15 volt, because you know Zener diodes go in two directions. The only thing, forward voltage I know for max for the series, according to the spec sheet, should be 1.2 volts, so that makes sense. That's the forward voltage, so it's 0.8 volts. 2.5 doesn't make too much sense to me. And then we go on to back onto ZD2. Okay, there we go. Well, hey, was I crossed onto the other one? Sometimes I was testing both at the same time. But yeah, that's the reading I was getting. 750 millivolts, 2.62. Yeah, that's the other direction. Hey, maybe I was just doing this for fun, not paying attention. Was I like that? Hold on one second. Yeah, that's what I was doing. But it's funny. I guess that's them together. They look like 2.5 volts forward voltage. The capacitance of this, the IR, that should be low. It's microamps. Capacitance 351 microfarads. So, something funny about these parts. I think I'm gonna unsolder one leg and test them out of circuit. But for now, I just want to test out, I believe C26. That's the one electrolytic in the power chip section. What's the number on that? It says, hold on. If I can see, yeah, that's C26. So I'm just gonna go ahead and hook it up using my magnifying glass, my lighted magnifying glass. Okay, I think I got one leg. Go from the opposite way. This little transistor. Damn it! Little transistor testers really really the business, you know. Now if I can only shrink my hands when I need to. Let's see what that does. Okay, so we have 958.9 nanofarads, an ESR of 2.9 ohms, V loss of 0.7. I'm not quite sure what V loss is supposed to be. So that's what, one microfarad. So 1 microfarad, and we had 2.9 ohms, 1 microfarad, so we were between very high and high quality. So yeah, that checks out. According to this sheet, 50 volts, if it's a 50 volts, is 4.5 volt. ESR is fine. This one doesn't even have the 1 microfarad. So yeah, that seems to test out okay. I think we had one of them that seemed to be a little iffy so far, but so far, and not really all that bad. So I'm going to come back. I'm going to lift the legs on the Zener diodes and see how they check out. Alright, see ya. Okay, I've lifted the legs on the Zener diode, and we are going to try ZD2. And we have a forward voltage of 818 millivolts, capacitance of 37 picofarads, IR of 2 nanoamperes, and it's just seeing it as a diode. Now, admittedly, what is going on here is that the internal voltage of this unit is limited to 5 volts. Okay, and if you look online, they even tell you the other voltage, the highest it can read up to is 3.9 volts. And this is supposed to be a 15 volt Zener diode. So this has a very limited usefulness for testing Zener diodes in general. So unless the other voltage is 3.9 volts or less, it's not going to see it. So I'm going to rig up a little testing rig to test those Zener diodes correctly. When I get that done, we'll continue. Okay, I've taken ZD2 out of the circuit, and it's right here. And I have my power supply here, and I am using a current limiter 151K resistor. So I'm just going to show you the available voltages that this power supply can push out outside of the circuit, of course. So I'm just going to unclip this circuit. Hold on a second. Just put that right here. Just prop it up. And my power supply can switch polarity and go through different voltages. So I'll just go through, switch the polarity. You'll see, go from minus to positive. Okay, so that's positive. And then I can go through many voltages. That's 1. That's the second third voltage, 4th voltage, 5th voltage, and lastly, you can go up to, as you can see, 17.5 volts. So I'm going to put it all the way down on the lowest. Okay. And I'm going to put back this circuit. second. So put one alligator clip to a tip, one to the other side. Okay, you can see that. And I will read the voltage difference across the Zener diode. Okay, 3.93 volts. I'm going to switch polarities. Hold on a second. See, that's 0.64 volts. If I switch the voltage up on my power supply, it doesn't change. So that's one side of the Zener diode. Now let's reverse the polarity again. Okay, so that's that reversed. Should be, hold on. Nope, I didn't reverse it. Hold on a second. Okay, that should be reversed. Yeah, 3.93. That's the lowest voltage setting on my power supply. So it goes up one. Now we have 6.5 volts. 8.54. Another one. Okay. 10.72. 12.84. Remember this is the last setting. Had 17 volts, so it is limiting the voltage to 14.7 volts. So I'd say on the whole that one is working, and I'm going to reinstall it, and we'll take out ZD1 and see if that's working correctly. So I'll be back. Just a little tip, when you're trying to solder these components back in the board, put a little scotch tape to hold them in, so when you flip it, they won't fall out while you're trying to solder. Okie doke. Everything looks good. So now I can solder this component back in, and it won't move back out while I'm trying to get it installed. Okay, that's one joint. And that's the second one. Okay. So just remember, when you're trying to do this sort of stuff, just put scotch tape, keep it in place, because it doesn't have the original length legs where you normally just would widen it to lock it in the board to solder than clipping. Since it's already been clipped, that's what you have to do. Okay, here we are testing now ZD1 out of circuit. It's right there. This is on the smaller breakdown scale, so region, whatever you want to call it. If I move up the voltage, stays steady at 0.66 or something, 6-7 volts. Okay, so we're going to bring that back down the voltage on the power supply, change the polarity. So now the voltage goes in the other way, and bring up the voltage one by one. Okay, here's another one that's reading 8.5 volts, about 10.54, 12.6 about, and there we go, 14.73 volts. So it's working properly, because we know that this power supply can go up to 17.5 volts, so it's limiting the voltage to approximately 15. Bring it back down. Okay, reverse polarity, double check. The other side of the Zener diode. And it limits it to about 2/3 of a volt. There you go. So it's working properly. And we will install that back into the circuit. Okay, so I decided to put the main filter capacitors back in because they seem to test really good, and I don't really see the point of replacing a part that tests really good, which is a testament to these newer generation filter capacitors, filter capacitors, and let's see, these would be the electrolytic kind, right? Yes. So I didn't really see much point to just replacing them for the sake of replacing them. If they test really good, what's the point of that? If they test really good, who cares? Right? So I'm just going to solder these back into place. And we'll discuss numbers later. The 100 microfarad caps, one of them looks suspect to me. So I'm going to probably get some new parts, and then check out how the new capacitors test in comparison. And depending upon how they test, I'll make a decision whether it's worth it to replace or not. Okay, that's one solder. Let me get the other leg. Okay. So what I'm going to do a little later on is get a glue gun and glue back those bases a little so they're nice and solid. Okay. Okay. Just to recap what I've done, we've no pun intended. We've looked at these capacitors in the power section, and this one capacitor in this is the power filtering section, and this is like the power amp section. We checked one here, and I'm documenting the results here. And you remember I soldered back the two main filtering caps, these two right there, because they tested great. And I figured what I'm going to do, I think these are the most important ones. I could be wrong, but I said, what the heck, I'll just lift a leg off each electrolytic, check off on the schematic and document it, and then we'll go through all the numbers at the end and see if we want to order a parts list or if it's really not necessary. But the two main ones I was concerned about, in my opinion, test perfect. That would be, like I showed you on the schematic, these two, and that's C35 and C36. Their capacitance was pretty damn close to 2200. The V-loss, I'm not quite sure what V-loss means. It seems okay. And the ESR was non-existent. So I said, a good cap's a good cap. Who cares if it's 18 years old? If it tests good, why mess with it? So I think what we're going to do is we're going to go. Here's an electrolytic here in the power amp section called C23. I think it's 1 microfarad or 10 microfarads, 16 volts. So I'm just going to show the process one more time, and then we're going to document it, and then I'll go ahead off camera and lift up all the rest of the electrolytics and show you the results and see which ones we may want to replace and which ones we don't. I already made the decision for these two, no, not to bother. So now we'll just lift up a leg off of that guy, and he's just to the right of that mounting plate. Trying to get my bearing. See, okay, so I know there's a resistor there. Okay, so he's towards the top. So that would be like one of these two soldering points. So just get my solder sucker ready. I'm just gonna heat up. One leg. That looks like it did it. There we go. I think that did it. I could have hit the wrong solder joint. See, this is, yeah, I might, yeah, I think I hit this, actually the ceramic capacitor. So I'm sorry for that. I'll have to resolder that back in. There we go. Is it still filming? I'm sure it is. So this is why we don't include lots of footage in these videos, because this is not really that interesting to watch, all the mishaps. So yeah, there we go. I lifted that one leg. And let's see if I can try to get my my probes to hook up. Okay, so I'm just going to stand up, reorient the camera, look at the tester. So we have V losses 1.2%. Like I said, that should be what, 10 microfarads and an ESR 1.4 ohms. Right? I want to say that's like 1 microfarad, but shouldn't that be 1 microfarad? You move over the decimal point three places, right? Oh no, because, yeah, I'm sorry, because this is like 10,000 really, right? That's 10,000. So if you move it, and then once you realize it's 10,000, move the decimal over 3. That's 10 microfarads. Okay, so 10 microfarads, and I believe it's a 16 volt rating. Okay. According to the schematic. And we had an ESR, I believe, at what, 1.4 ohms? I'm just doing the tester again. Now it says 1.3. So 1.3 ohms, 10 microfarads. So according to this sheet, we're between high and normal quality. For 16 ohms, for 16 volt, 10 microfarads, it says 8 ohms, so it beats that. Here's, according to here, 16 ohms at a 16 volt. so it beats that as well. So yeah, I'm just going to go ahead and I'm just going to do this procedure to all those electrolytics, document it, and then we'll see. But yeah, you don't have to see the majority of this. Alright, I'll be back when I'm all done. Okay, it's been months since I last filmed anything on this, so I'm sort of starting fresh in my mind. I think I'll try to figure out where we left off. But I think what we're doing is we're checking out the health of all these electrolytic capacitors on this board. Now, is this in the frame? Yeah. So, and I think I last said I would check each one and compile a list. And I went ahead and did that, and I kept my schematic and went through each capacitor. The only one I didn't touch was the one over here on the you know, the outlet or outports, whatever you want to call it. You know, these things like line out. There's like one electrolytic right there, and I'm not going to bother with that one. Not that important to me. So I went ahead, compiled this list. You know, C3, C11, C13, and I did the measured capacitance. Of course, you know what it's supposed to be. In this column I put the V-loss, the ESR, and I took those 4 sheets, and for each sheet I compared these values to see how they compared. And where I checked each sheet, you know, obviously it's good. And if you see more X's where it sort of failed, like here's one and it sort of failed from this spec sheet, you know, one of these 4, whatever. And then here had one X mark before I get down to here. This 47 microfarad 16 volt, I think, had 2, and had quite a big V loss. Although the C40, if memory serves me correctly, it's this capacitor right here. And sometimes, you know, that's going into the the Reverb Tank. It's on the schematic. It's like physically near where the clipping diodes are, although it's not in any way connected to that part of the circuit. It's part of the leg of this op amp that feeds the Reverb Tank. So that was somewhat questionable, but you know what? Who knows? Maybe that's part of the charm. You know, part of the charm of these old circuits are components that really don't test perfectly to grade. However, the ones I don't think have any charm are perhaps what we call the filter capacitors. You know, right after the power transformer, it's taking the rectified signal from the secondary side of the power transformer and trying to smooth it. And that, I think, can get as high tech as you possibly can get. So here we have, let's see, C31. That's the 1 microfarad. That was okay. That's not it. It's been a while for me. Yeah, the two big ones that I deemed they're good in the videos before are these 2, and everything checks great. Everything checks great. That's why we soldered those 2 back in. And then the next 2 in the line, the next 2 smaller ones, are the 100 microfarad 25 volt capacitors, and they had 1.4 and 1.3% voltage loss. And this guy had a 0.34 ohm ESR, and this one had 0.52. And when I started checking the spec sheets, 3 of the 4 spec sheets, it failed for that requirement. It's like, oh. So what I went ahead and did is I ordered some new capacitors, and hopefully it's in the field. Yeah. Some new old stock, I believe Nichicon. I'll just take them out at random. And I said, well, if that failed, maybe I can get a match too. Maybe I could improve the performance, right? Okay. So I just pulled this one out. Let's see what it says. Voltage loss 1.6%. Here, one in question is 1.4. ESR 0.61 ohms. You know, the issue with these charts is, you know, you don't really know what's normal. And like I said, I constructed this thing to see if I could see patterns. You know, without having experience, maybe I could see patterns that are something's amiss. So I'm just pulling this out at random. Try that again. (422 picofarads). Here we have a nice one. V loss 1%, but still 0.61 ESR. Alright, we're just going down the list. 0.52. I think what we're doing with this is we're going to do something called inductive reasoning. (1.62 ohms ESR). Basically, you know, when you're a kid, you'd open up a box of Cracker Jacks, right? And you put the first one in, it was delicious. And every once in a while you got one of those boxes that were bad, and you put it in your mouth and it was sour and disgusting. Let's see what this one says. 0.62, 1.2% voltage loss. Whatever voltage loss means, you sort of think you know what it means, but when you go research it, no one really knows. And yet, so you pop in another Cracker Jacks in your mouth, and it's disgusting. 2.2% voltage loss, 0.6 ohms. Then you put a third Cracker Jacks into your mouth, right? And you spit it out, and it's disgusting. And then you do a fourth. After the fifth, look at that, 0.61. After the fifth or sixth one, you say, screw it. This box of Cracker Jacks is bad. Now, did you eat all 550 of them to deduce it was bad? No, you, as a kid, you knew that you wanted to a sequence of bad ones, and the 0.6 ohms ESR, you're into a sequence of bad ones, and what's the chances that anything's going to be good in the box, you know? And similar, we're going to get an idea, because these are new capacitors, or maybe new old stock, what these capacitors should be. 0.61 ESR, you know? We're going to come to a conclusion without testing every capacitor in the universe what a reasonable ESR is for these capacitors. 0.64 ohms. And just to double check, these are Nichicons. These are 25 volt, 100 microfarad, 105 degrees Celsius, and these are the PJM series. Okay. I'll do another one. Here, maybe I got one there too. Hold on. .5% voltage loss, 0.61 ESR. And lastly, this one is out, just hanging out. Let's see what's going on with it. Ooh, that's a low voltage loss, 0.8%. And look, I got a nice 0.59 ohms ESR. So, after testing all these, we can, is it induce a word? Or we can conclude through inductive reasoning that this 0.52, despite the fact that on these charts it seems to fail, that's probably a pretty reasonable figure. And that one is actually pretty dang low. That's a good capacitor. And from what my little understanding of what ESR is good for, it probably, for something like 60 hertz, 120 hertz, it's not even that important. 0.58 ohms. It's something like when you get to really higher frequencies that it becomes important. You know, something like perhaps voltage loss for this application is probably much more important. So, what we've done is we've gone through all the capacitors, save this little one and this little outboard for these, you know, like the line out, this, that. Maybe I'll test it. I don't know. It just seems like a pain in the butt to get my soldering iron there. But yeah, all the capacitors test good, so this has been basically a health check. You know what they say, oh yeah, I gotta replace all those capacitors, you gotta do it, you gotta recap, blah blah blah. Well, sure, you gotta do a recap on old crusty things from the 50s and perhaps the 60s, and back then when those capacitors were new, they probably weren't designed as well as these. As I was saying, the camera just quit on me, but yeah, the idea that these electrolytics automatically go bad after 20 years, or that's a long time, is not necessarily true. So we've tested them all, and everything's in range. Everything seems cool. I mean, I don't, other than perhaps this guy, which is on this leg of the first op amp that's driving the Reverb Tank. I mean, that could be giving you some flavor. You don't know. I mean, there's maybe in the future I'll dig into that one. Who knows? But yeah, it's been a learning experience. So what I'm going to do is going to set up the soldering iron. I'll get back to you in a second, and we'll just poke a couple of these through, and then I'll just finish up off camera, reassemble it, and get this amp back and work in shape. Alright, so I'll be back. Okay, I'm just going through my work and resoldering capacitors and checking off the ones I did so I know where I'm at. So the next capacitor I want to go after is a capacitor C13 or C15. So that would be these two joints right there. just want to wiggle those around and make sure they're in there. Let's see, so yeah, I have to get that in. Oop, there we go. That leg is in. So just take my solder and soldering iron, heat up the leg, there we go. So I can check off C13. Now I just got to press back the leg for C15, and I'm going to go ahead and do all that, and I'm just going to check for any bad solder joints in general. So when I'm getting close to the end, I will we'll get back, right? But this isn't too interesting to you. Okay, interesting turning of events. In the process of trying to remove these capacitors, with just one leg from the other board, sometimes I desoldered another component that was right next to it by accident. Easy mistake. And one component, I think about 2, maybe 3 components accidentally unsoldered that I was about to solder back is a capacitor, but it's a ceramic disc capacitor, C24 right here, and that's in this, the power op amp stage. It's like the filtering or feedback or whatnot. Hold on a second. No. Alright, so I'm back, and like I was saying, there's this capacitor, like I said, C24 in the output section, the power op amp stage, and I just decided to test it, although I don't think of testing the ceramic caps, but I got the legs on it. No unknown or damaged part. So that's a fortuitous moment. I'm going to take that out because sometimes that ceramic dipping goes onto the legs and maybe I'm not hitting the metal part, but I'll take that out. We'll test it out of circuit and just double check. But that's a good find. Alright, so I'm going to go ahead and do that. Okay, according to this circuit, it's a 104p ceramic disc capacitor, so it's a, what is that? It's 100 microfarads. 100 nanofarads. So when tested out of circuit, 104.5 nanofarads, 0.7% loss. So it's good. It's going back in, which is always a good thing. Okay, so that'll go back in, but it was worth a check. Just, sanity check. Okay, we'll be back. Okay, so I've gone through and I've soldered back all the capacitors back into place, and what I've done is I've slowly gone over with the magnifying glass, and preferably you want one that has like an inner magnifying glass, like a 15 power perhaps, and that's, you look with the larger one, you examine as close as you can, and if there's one that kind of looks iffy, you home in on it. Now, so, and when I found something that was questionable, I took this magic marker and I put a dot next to it so I wouldn't forget where they were. The alternative is to just do all of them, but that's very time consuming, especially if there were no issues. So I'm just going to go and touch up the ones I thought were iffy. I think there are like 5. Just maybe add a little bit more. Okay, that's one. Sometimes you just see like a little crack, or like the base, or the amount of solder doesn't look to be that healthy. It's 2. Or someone like skimped on the solder the first time. Yeah, that's true.
You know, when they're making tens of thousands of these on the assembly line, you know, it's a miracle any of them work. So I'm just going across, doing all the ones that looked iffy. Like I said, if you really wanted to spend a lot of time, I think that's all of the ones I marked, you could go and reflow the solder in all of them. What we will do is, I think it's important, these PCB mounted pots are infamous for cracking, so we probably should just reflow that. They're just infamous for giving issues, you know, just as a matter of course. You just never know. I mean, because they get the most stress. Just a little checkup. These look really weak. Yeah, and just go down the line, you know, just touch up joints. That's that. The guitar mounted, these big solder joints for the guitar jack looked really solid, so I'm not going to touch that up. So there you go. And that's your first stab at doing a capacitor check. You know, I was thinking, you know, these electrolytic capacitors would have been worn out because that's all the internet lore. It's like they all go bad, blah blah blah, but they all check perfect. In fact, I checked the one capacitor. Remember earlier, C31, I had or C33, I had 0.52 ohms ESR. It went dropped back down to 0.45. So yeah, everything's great. So we're gonna just go ahead and start reassembling and see what happens. So I'm just going to come back and I'm just going to get the scoop, going to clean that up and reapply this this heat sink gel or whatever you call it. So the power op amp chip gets how can I say, connected to the chassis, so it can get rid of as much heat as possible. And I think we're going to put a little bit glue down on these primary filter capacitors so they don't budge, because they're quite big. So we'll be back. Okay, so everything's soldered in place. Now we have this glue gun, and I'm just going to put some glue on the big filter capacitors just so they're stable. Okay, that's all set. And now we've got this out in the open. What you want to do is you want to take this deoxit spray and spray it into the little holes of these potentiometers like so, and then you're going to want to spin the knobs a few times. So we just go, and then you just spin the knobs, because while this board is out, you have the opportunity to get this contact cleaner and lubricant into these pots, so no chance of having any issues with them. If you don't do this step now and you bolt everything back together, then you know this is going to be, you're going to have to take it all apart, and that's no fun. So it doesn't require much energy to get these potentiometers nice and lubed up, and so we can have nice scratch-free performance while it's installed. So you just want to spin these guys a little bit, you know, it doesn't take much. And you'll be amazed at how long this treatment lasts and gives you worry-free performance. So you want it to feel nice and smooth. So that feels good. You just run these back and forth. That feels nice and good. Nice. Oh yeah. So yeah, you just want to do that. Just 1 or 2 sprays, circulate everything. Move the knobs back and forth. And that's it. That's all you need to do. I'm just going to do these last 2. And that's all the deox that you need to put in these guys. You just want to run these back and forth, and now they're super smooth. This one's still a little stiff, so maybe I'll put another dash in him. But yeah, that's it. So that's that, and I'm gonna let that glue dry, and then we'll get back to the next step. Okay, next step is we want to clean off this thermal joint compound, the old stuff I'm going to reapply. So you want to get like some sort of solvent, like a nail polish remover. I'm using something I had. This is called Clean Wood Cleaner. It has all sorts of strong solvents. So you just want to take a paper towel, douse it. And then wipe off the old grease. I'm sure maybe it could probably be reused, but you know, why bother when we have plenty of new grease that we can reapply. So that surface is now clean. Okay. So we also want to clean up the face plate. And that's easy enough to do. Just get any sort of cleaner, and here I have maybe what's called Meyer's tub and tile cleaner. You know, anything surface cleaner is fine. So I'm just going to wipe the top up. Give the panel a good clean. And now we can, I believe, start to assemble this project. So I am going to take out, this is stuff when I was working on computers. It's called Thermal Joint Compound by Thermal Alloy Inc. And it's what we used to use for those heat sinks on the CPUs. So it's good enough for that. It's good enough for this. So we're just going to spread it on. Looks to be a lot of clear stuff too. Actually, I might reapply that because it seems like there's some sort of separation. So let me just get, because I think the white is like the carrier. I want to get that white stuff. Probably helps to maybe buy the stuff fresh. See if I can get any more. Well, that should do. Of course, it's leaking out onto the board. So I'm just going to prevent that from happening further. Of course, a bunch of the good stuff got leaked on. That's okay. So just leave it like that for a second. And if there's any mess on the circuit board, you can just take more of the solvent that you're using, be it nail polish remover or whatnot, and just clean up the board. because it's electrically conductive. And what I'm going to do is I'm going to go ahead and I'm just going to get some Q-tips to clean the remainder up, make sure that doesn't stay on the board. So we'll be back. Okay, everything's clean and ready to assemble. So just tip this over so you can see this operation a little better. We want to get the circuit board, get these pots in behind this sheet metal fold. So you sort of want to tip it over here and then inward, and then we want to fish those pots into the holes. One thing we want to do, there's these two washers and they're going to go onto the underside of the input jack. See if I can show that. So right there I'm going to put these two washers in. We're going to sneak this board up into place. I believe they both go in here, sort of make up for the gap. And then, you guys don't see if you can see that as I'm doing it. I'm going to try and sneak in all the pots into place. There's one that seems to be a little not aligned very well. Let's see if we get it there. There we go. Okay, so we have success. Okay. So the next thing you want to do is we want to start putting on the washers. You know, get a loose fit going. Make sure these are all through. Toggle switches in. The LED is in. So let's see. Okay, this side. So yeah, you're gonna put the washer on over like so, and just get these nuts started. No reason to tighten them down too much. Very simple. We don't want it too tight because we're going to want to align the screws to push in to bolt the heatsink into the chassis. So if these are too tight, it's not going to be able to be in the right place. Now, if it was just me, I'd like to test it without having to bolt it back in. But you know, there's going to be a metal part that touches and it will short and everything will go up in smoke. That's not good.
Yeah, there's two more.
See, these pots serve as a second function of actually holding the chassis in place, so that's why we did reflow of the solder joints, because these are under a lot of stress compared to all the other components on the board. They actually support this whole assembly in. Okay, let's see. Okay, and then we got the jack bolt, and reason why, I don't know if you can see it, but you can see like the two washers there. That's just to make up for the gap. Okay, and so it's not overly stressed. Then you just put that nut over it. Okay, let's see, what else do we have to do? Oh, the toggle switch alligator clips. These guys need to go back on. I don't know if you can see that. So just put them back on where they belong. Okay, so now there's this excess grease that we're gonna probably want to clean up. So I'll go ahead and clean that up, and then we will test it out. Hold a second. One, and yeah, these go to the speaker. So once I get all that grease cleaned up, we will test it out and see what happens, and that's before we do the final bolting into the cabinet. Okay, so I'll be back. Got one thing that I was just talking about. Here are the two screws that are going to go and tighten up the heatsink to the chassis. So you want to hand start them. Already feels tight. 1 second, there's already glue. Okay, yeah, see, you have to push it to place a little bit and do some maneuvering. It's important to get these hand tight before you start clamping down. You don't want to strip anything. Yeah, that one's going in nice. Okay, that's the clamping force that's required to make up the gap between the piece of metal, the heatsink on the output op amp, and this chassis. So it makes a good, solid conductive contact. Okay, so I'm just going to go clean this up and then we'll be back to test. Okay, I have a speaker cable connected to the speaker in the Pathfinder box. Alright, I have this the back plate that's telling me which jack to put the exterior speaker. So that would be this jack. Let's see if I can find the speaker cable. It's just a Planet Waves speaker cable that has the spades on the end, and I have it connected to another one. Okay, so here we go. We are plugged in. Alright. And now I'm going to plug in the power. Oh, 1 second. Let's plug in.
Does it have to go to the sides to put on that too?
The ends? No, it fits inside a speaker cabinet. It's a good question. This fits inside a speaker cabinet, so that gets hidden. So I'm going to plug my guitar into the jack. Okay. So its speaker's connected. Now we just got to power it up. And hopefully it doesn't blow up in my face. And we should really well, it was on. Okay, so now I'm going to switch it off, then I'm going to switch it back on. And it's out of its cabinet, so it's got a lot of noise. Now let's just play around with the controls. Okay, so that's everything on 0. Gain, volume. Seems to be working, right? Well, it's hard to tell where the controls are at.
Does he have a phone?
Yeah. So there that is the electrolytic capacitor check of a Pathfinder. I think what we will do as well, this back plate, I might get let me just shut that off. I might get some of that metal tape to cut down on interference and just line up the back of this, and then we'll see how that goes. But yeah, for now, it seems to be working. Hasn't blown up in my face. How about the tremolo or the reverb? We'll test reverb. How's that? Reverb works. How about like some tremolo? So let's see, this is tremolo speed, and then this is tremolo depth. Okay, tremolo all the way up. Now bass, maximum bass. Minimum bass, maximum treble, minimum treble. Now how about the gain? Okay, say it's a success, and we'll get it back into its little combo speaker cabinet. And I think you probably don't need to see that. All right, thanks for tuning in to the Vox Pathfinder 15R channel. Okay, so it's bolted all back together. You know, nothing surprising, nothing shocking. See how it sounds. Well, we already did a small test anyways. So I'm in the bridge pickup of the Epiphone SG with the push-pull pop pull, so it's just single coil. Up on 10. So reverb definitely works. Let's get some tremolo action going. Okay, let's switch over to the bridge. Humbucker, volume on 10, tone on 6.5. Okay, tremolo's off. Let's just see how it cranks. Notice the touch sensitivity. I can now, I'll strum lightly, and it cleans right up. Now I'll do a little harder. Now I'll hit the strings really hard. Okay, so that concludes the video. We looked at all the electrolytics, and they all tested fine. So we'll just leave it at that. I know it's no younger than 2008. That's when they stopped making these black grilled cloth versions. So it's at minimum 12 years old to about maybe 18 years old, 2002-ish I think, or 2001. So yeah, the electrolytics are good. No problems. Nice, sweet violin-like tone.